Hi, and please welcome to this topic on exploratory data analysis (EDA). EDA is a very important step in data analysis. Hopes, before I continue, my name is Oladebo Ayoni. However, the primary purpose of exploratory data analysis is to provide better understanding about data variable and relationship between datasets. Meanwhile, there are two types of exploratory data analysis: one univariate, two and multivariate exploratory data analysis. Before further ado, let's go to our digital notebook for this practical exercise on exploratory data analysis. Thank you. Welcome back on this practical exploratory data analysis project EDA on soft drink soda sales. However, our overview on this project contains the track sales of various beverages in the United States of America from three different companies breakdown, e.g., sales figure, cost and profit by product, category, and customer location. And each row represents a unique product sold in a particular region. Meanwhile, on the content A, here are the business objectives of our exploratory data analysis project. 1. What is total revenue generated by each company? 2. Which product is the most sold based on units sold? 3. What is the profit margin by company, that is, profit as a percentage of revenue? 4. Which state has the highest sales in terms of revenue? 5. What is the relationship between units sold and profit? 6. Which product category generates most revenue? However, by this, will lead us to content B, that is data analysis. And our data analysis dataset for this project was being downloaded from data.org. And here is the website we download data from, data.org. And here is our file in Excel, that soft drink dataset. And on column A, we have product. On column B, we have company. On column C, we have category. On column D, we have units sold. On column E, we have revenue. On column F, we have cost of goods sold. On column G, which is profit. On column H, we have purchase date. On column I, we have customer name. On column J, we have customer state. And column K, we have customer city. And column L, we have customer zip code. And column M, which is the last column of customer order ID. And by this, will lead us to content C, which is presenting findings and recommendation. And before we go further, let's go into our data analysis to import the required libraries. Let's first and foremost import our pandas, that is import pandas as PD. Let's import our matplotlib, import, that is for our graph, matplotlib, matplotlib as dot pyplot as plt. So let's import our cbones. Import our cbone as cns, cbone as sns. So right now, on data analysis, we've import our required library that we're going to use for this particular project. We import pandas as PD. Then we import matplotlib dot pyplot as plt. Then we now import our cbone as SNS. So let's run this and see what will happen. As you can see, it is running. So just let us allow our import modules to run. Good, it has run. So let's go to data collection by calling for our data set. We said pd dot read underscore excel bracket close, then hyphen. Then let's call our data set. That is suffering data set, which is this. Let's call it. Then let us store in a variable. That is, let's say df equals to pd.read. So let's run our data set. It's running. As you can see a star. Good. So let's call the first 5 row. Let's write the markdown. Call first 5 row. First 5 row of our data set. That is df dot add. Let's see the first 5 rows of our first data set of solving data set. Let's run this. Good. As you can see, that is our first 5 rows of our data set. So let's call the bottom, that is the down button of our data set, and see what we have there. Let's be markdown. That is the last 5 rows of our data set, and see it. Let's view it. So by then, we sell df dot tail bracket close. Let's run it. Good. These are the last button of our data set. Let's call now, since we've seen that, we are now going to number 3, which is data processing. Let's call the column of our data set. Let's find out df dot column. Let's run this and see what we have. That's the column that we have. We have product, company, category, unit sold, revenue, cost of goods sold, profit, purchase date, customer name, customer state, customer city, customer zip code, and other ID. So let's see the shape, the f.shape of our data set. Let's see the shape. We have 10,000 rows and 13 columns. If you can count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That is 13 columns and 10,000 rows. So now let's go to the next one. Let's give a cell so that we're able to continue our project practical. Let's find out for null value in our data set. If there's any null value, let's find out. Let's check for null value, if there's any for null value in our data set. Df is none bracket close. And moreover, if you find this line, let's run this and see what will happen here. You can see this is the Boolean way. So if you want to see it is false, but we want to see the value in numbers. We now have to put dot sum here, then bracket close again. Then we run it. You will see that it gives us in numbers. So right now we don't have no value in our data set. as you can see. So let's drop the column that we do not need in this matter. Let's go to the next level. That is, let's drop the column because there's a column that we see on this data set that we not do for this data exploratory that we're going to do. So let's drop the one that we don't need. So let's drop the column that we not need. We do not want or need. Anyone want or need. So let's drop the column. Let's say the f dot drop bracket close square bracket we have columns equals to, then let's check the column that we don't need here. We don't need, let's see, we don't need, I think we don't need a customer name, and we do not need a customer name, customer city, customer zip code, and other ID. So let's drop those ones. We are going to drop customer name. We have to be very sensitive with the letters. If it's capital letter, let it come capital letter, or if it is small letter, let it come small letter. Otherwise, if you put what's supposed to be capital letter and a small letter, our code will not run. So let's be careful on this. We are doing this. So what is customer? We have customer name, comma. We have another one called customer city, then we have customer zip code, comma, customer zip code, and the last one that we don't need is customer ID. Other ID. And meanwhile, we now set customer ID, comma, in place so that we have a very constant data. Our data frame will be constant here, so we have to make it permanent. That's why we are putting this in place. So we have to make that after we run this, we have made that very permanent on this. That's why we are putting in place equals to true. So let's put it in place equals to true. So let's run our code. Let's check again. Customer name is there. Customer city is there. Customer zip code is there. Then other ID. So let's run our code. Let's run this and see what will happen. No, there's an error somewhere. That's why I say you have to be very careful. Our columns, you can see our column is not complete. There's also be hen here. So let's run it again. Good. After that row. So let's see the first 5 rows of our data set after dropping the column that we do not win. Let's see the first data set, first 5 row after dropping the column, dropping our column, dropping columns that we do not want. By calling the f dot head bracket close. Let's run it. As you can see, after we drop our column, customer name, customer city, customer zip code, and other, these are the rest column that we are going to use in this particular data set. I think We can see we have product, company, category, unit sold, revenue, cost of goods sold, profit, purchase date, and customer. I think we need to do purchase date. I think we need to drop it too as well. Let's drop purchase. I don't think we will need purchase date on this start. Let's drop the purchasing date. It doesn't for purchasing date. Customer. Let's put purchasing date. Purchasing date does not count here. Let's drop the purchasing date again. We have purchase date. Don't need it. So let's run it again. Let's run our data set. Oops, there's a mistake. So what is the code? Say customer name, customer name, but not found in axis. There's something somewhere wrong somewhere. Purchase. Does it correct? Purchase date. Something wrong somewhere. Coming. Let's run it again and see what will happen here. Let's run this. Oops. There's one thing here. Customer name, zip code, other ID. Not found in ASICS. Let's run it once and for all again. Let's start from the beginning again and start because I think let's run this. Let's run this again. Let's run this again. As you can see, that's the reason why we're there. So you can see now we have seen our new purchase date hasn't been dropped. This is still there. Why? It hasn't been dropped. I don't know why. Something is wrong somewhere. You can see it has dropped. Didn't run it, that's the reason why it doesn't drop from. So right now our purchase date has been dropped. So we now have how many now? We have product, company, category, unit sold, revenue, cost of goods sold, profit, and customer state. So let's go ahead and let's see to confirm if we drop missing record in our data set. No, let's see. We've not seen information of our data set. Let's see information of our data set. Let's information of our data set. df.info. You can see df.info. That is in series or in data frame. You have to put it. You can see that is our dataset information. As you can see from the drop down that we did now, after we drop our purchase column that we don't need, purchase date, customer name, customer city, customer zip code, and other. We now check for the information that we have. These are the information that we have left. We can see we still have 10,000 entry rules. Understand? And we have 8 columns. So our product ID is an object. Our company is also an object. And category is also an object. That unit 2 is called an integer. That is revenue 2 as well. And can see the data type of our data set in 64. And I can see the object and I see memory usage. That is 25.1 KB. So now let's see confirm if we are still having a missing record by saying let's just write it down. Let's confirm. Let's confirm if we are still having missed record in our data set by saying df dot is now bracket close dot any bracket close. So let's run it. Let's confirm if we are still having any missed record. Let's confirm. False. We don't have any missed record. Let's also check if we still have any duplicate to be sure. So let's confirm if there's any duplicate as well. Confirm if there is any duplicate in our new data set. By saying df dot duplicate df dot duplicate brackets close. As see is false, as you can see. So right now, what next for us to do is to find the statistics of our data set. Let's go down and find our statistics of data set. Let's find the statistics of our data set by calling df.describe bracket close and run it. So this is our static data set of our new data set. On this data analysis, exploratory data analysis of soft drink soda sales, we have on the min max, minimum is 100, then the max is 100 millions. You can see, then you can see the count, the mean and standard, as you can see. So right now, what we need to do now, after getting our statistics, so we need to get the unique values of our category value. You can see the data set that we have some category value in our data set, like for example, products, company, and category, apart from the customer state. So let's find out the unique value for our category value. Let's go. Let's put another cell again. We have say, let's find the category value of our. Let's find the category unique value. Let's say let's find the category unique category for data set. Find the unique category of our data set. Now say df bracket square. Let's find what again. Let's check product. Let's check for product first. Product. In that particular column, we are looking for the particular unique on that particular product column of product. Let's find for the unique value of it. So let's say dot unique. So let's better close it and see what are the unique parameters on that column. So the parameter unique on that particular column is coffee, wine, green tea, vodka, lemonade, cola, energy drink, herbal tea, beer, black tea. And let's copy this one and find for the other category value as well too. That means that we are doing machine learning. We have to convert this to numerical, but right now we are doing exploratory data analysis. So we have to just leave it that way and do what we need to do about this exploratory data analysis. Let's copy this one. We have to copy this. We remove this product. We turn it to company. We have company as a category value over there. Company. So let's run this one too. Let's see the unique value on that particular column. We have Coca-Cola, Dr. Pepe, and Pepsi. These are the companies that we are working on. Coca-Cola, Dr. Pepe, and Pepsi. Let's check for the other one category. Let's check for the category. Category. Let's see. Category. Let's copy this and paste it here. We have category. Category. So let's run this one and see. A particular column. Oops, there's a mistake somewhere here. Unique category dot unique. Category is not correct. Let's check our mistake here. There's a mistake somewhere there. Category. Okay, the F dot category. What's happening here? I think there's a unique. Let's rerun it and see what will happen here. Category is there. What happened here? Our data set. AOY scanning string literal. Wait. Let's see what happened here. Let's write our code. Category. As you can see, our category value we have is coffee, alcoholic, tea, and soft drink. These are our category and they are object. In the mean that we are doing machine learning, all these unique values you have to convert it to numerical so that when we are doing our analysis in machine learning, we'll be able to have numerical data instead of having this. But right here, we are doing exploratory data analysis. So let's focus on this and continue. So right now, what next for us is to present findings and recommendation. So what we need to do, we need to go to the section at the content, say the business objective. Let's say what is the total revenue generated by each company. So let's start it by the business questions that we have. We copy it and we paste it here as our question number 1. Where is it? Oh, present findings. Oh, let's put it here. Let's put it here. We said dash quantity question 1 number 1 question 1. So write in full. Question 1. Let's put us here. So we run it. That's question 1 first. Let's delete this one. It's under present findings and recommendation. Let's delete this one. Let's delete this one too. So we have question 1. What is the total revenue generated by each company? However, by this, we need to group the company and sum the revenue by applying bar chart. That is, our company underscore revenue is equal to df dot group by company revenue and sum. So let's give a markdown here. So we need to group the company. We need to group company and sum assumed revenue. We need to group the company and sum the revenue by applying bar chart. So let's go for that. That is, we said company plotting we say company underscore revenue equals to df dot group by close. Company
square bracket revenue dot sum bracket close. PLT dot figure bracket close. Fig size equals to bracket close. Let's put size of 8 and 6. Let's put that. Say company revenue dot plot bracket close. Kind is equals to kind equals to bar comma color equals to say blue green blue green comma and red. PLT dot title bracket close. Total revenue, see total revenue by company PLT S label dot S label bracket close. Total revenue PLT dot Y label bracket close. Total revenue total company total let's see it's total revenue and this will be X will be company, that's our company. So let's go to the next line. You see PLT dot S bracket close. Rotation equals to 4 5. PLT dot show bracket close. So let's go through it once again. Company revenue equals to DF dot group by company revenue then some sum square bracket and bracket close. PLT dot title total revenue PLT dot title total revenue by company is revenue total revenue by company X label is equals to company, then PLT dot Y label is equals to total revenue Then PLT dot S ticks equals to rotation equals to 45, and PLT dot show. So let's run this and see what we have. Good. So this is our diagram for the three companies that we have. Our total revenue is on the y-axis, while our company is on the x-axis. That's dependent variable. You can see the ranges. You can see the Coca-Cola is on the blue color, Dr. Pepper is on the green color, and Pepsi is on the third column. So this is how it goes. You can see the increases is 1.75, almost above for Coca-Cola, followed by the Dr. Pepper and the third which is Pepsi. So this is how we are going to do this. So let's go to the next question. What did the next question say? He said, let's go to the next question. He said, what product is the most sold based on units sold? Which product, which product is the most sold based on the units sold? So let's go. Let's go to the second questions. That is question number 2. So let's go to the next cell below. Then let's copy these questions. No, let's copy this. Let's copy the second question. Copy this. I will paste this here. That's the next question. So we said question number 2. So let's put in the markdown. Let's take this to markdown. Question 2. Let's run it. So that's question 2. Let's go to the next line again and give us the answer. That is question number 2, which says, which product is the most sold based on units sold? However, here, first and foremost, we also have to group by product and sum the units sold. So let's go to our markdown and say here we need to first and foremost also have to group by product and sum the units sold with the following code. We say product unit sold equals to the f dot group by bracket close product square bracket unit sold dot sum bracket close. So right now, then we now sort values to find the product with the highest unit sold. So let's quickly write another markdown. See, we now sort the value to find values to find the product with highest unit sold, highest unit sold. Then and print this format rows F formatted the most sold the most sold product is curly brace. We have said most sold product inside most sold product with mass unit sold, mass unit sold. Close it. Then we now said unit sold dot unit sold. Then before we now plot our graph, plot the total units sold for all products. Now said plotting our total unit sold for all products. By copying the first method that we used earlier on for our plotting. Let's go. We say product unit sold. We said product unit sold, but I have to go through it very well. Unit, this one is okay. Unit sold because of the F dot group by products bracket close square bracket unit sold dot sum bracket close. Then we will now sort the values to find the product with highest unit sold by printing our F format the most sold product is most sold product underscore most sold product with mass unit underscore sold. Then here we have to pull most product and get let's see, no finish word. So before we plot our graph, let's see something. Where does it here? It's not supposed to be here. Here is supposed to be right here. No. So let's run this and see what we have. Let's copy the first our plot code, plt dot. Copy this. Have to paste this underneath. Command V. Then let's run it now and see what we have. Oops, there's an error somewhere. I think our code is not complete here. From sort, let's define before our print format, that is most. Let's define before our print format, that is most sold products equals to product unit sold dot idx max bracket close most sold products equals to product unit underscore sold dot idx max bracket close. Then you now say mass unit sold equals to product underscore unit sold dot max bracket close. I think here should be capital letter. Unit sold and here is supposed to be unit sold most sold products equals to product underscore unit underscore sold dot idx max bracket close. Then mass underscore unit underscore sold equals to product underscore unit sold dot mass. Then let's change our this figure size to 10 to 6. Let's change to 10 to 6 and change this company revenue that we copy from the above earlier graph and change the company revenue to product unit sold. Let's change this. Product unit sold. The plot. Then let's change this to light green. Let's change the color to light green. Light green. Then let's change the title. Let's change the title to total unit sold. Total unit sold. Title to total unit. Total unit sold by product. Total unit sold by product. And change our S label to products. And I'll also our Y label to total units sold. So let's go through it once again. So I will run it once and for all. Total units sold because of the group by product units sold, the sum most sold products, cost of product units sold dot id x marks power close. Let's check again before we run it. Let's check. Good. Good. So let's run it again. Total units sold. Let's run this and see what happens. Great. As you can see, this is our graph. The most sold product is 20, which is 5 15 550 569,303 units sold. You can see this beer, this lactic, this coffee, this cola, this energy drink, this green tea, this herbal tea, this lamodi, and this vodka and wine. These are the products which are on the x-axis, and total unit is in the y-axis. So as you can see, it is the green tea that are most sold in terms of unit. You can see it. See this. See where is green tea? This is green tea. There's the tallest out of them. Out of them. So that is that. So let's go to the question number 3. We don't know question number 4 and number 3. Number 2, I mean. Let's go to question number 3. What's question number 3 says? Number 3 says, what is a profit margin to by company? That is profit as percentage. We are looking for profit margin by the companies involved. So let's copy this. So go down. And paste it here. Let's say question 3. Let's run it in markdown format. Let's run it. Let's go to the next one. Cell to answer the questions. So let's calculate the profit. Since the question based on profit as percentage of revenue. So let's calculate the profit margin to each company. Let's go to markdown. Let us calculate the profit margin for each company. Say DF square bracket profit margin equals to DF square bracket profit divided by profit divided by DF square bracket revenue times 100 times 100% times 100 times and by this let's also use group by. let's also go through group by and then we calculate means profit margins. By saying, say, company profit margin equals to df dot group by bracket close company square bracket profit margin mean bracket close. Let's copy our formula that we used earlier on for plotting from the above. Let's copy to make it very snappy so that this thing will not take time. Let's copy this one again. Let's paste it. Plotting by changing the product sold to company profit margin. Company product margin, and also change the size, fixed size to 8 and 6. 8 and 6. Then we change the color to orange this time around. Orange. Then we change the X label to company. Company. Then we change our Y label to profit margin in percentage. Profit margin bracket close percentage. So our action remain the same and our person remain the same. So let's go okay, company, this company, okay, dot me revenue profit margin df dot group by plotting company project margin for the products. Then what else do we need to change here? I think we are good to go. Let's say title profit to margin. Our title, we have to change the title, not total unit, from profit margin by company to profit margin by company. Percentage we have to put percentage sign there. So then run our code for question number 3. Let's run it. Oops, there's a typing error. Company product margin is not defined. So our error, let's correct our error. What's the error? 11. Company product margin. There's a company profit margin, not profit quota. Yeah, here's our error from. Let's correct it here. Profit margin. So let's run it and see what we have here. Good. As you can see, these are profit margin by company in percentage. As you can see, Coca-Cola and Dr. Pepper and Pepsi has the highest margin percentage. So let's go to the next question, which is question number 4. Question number 4. What does question number 4 says? It says, which states have the highest sales in terms of revenue? So let's copy this. Go to number 4. Let's copy it. Number 4. Business objective. Number 4. Paste it here. Let's give it a markdown. Let's put the markdown. We have question 4 and run it. Good. Let's put the cell too. So, as we said, question 4. Which states have the highest sales in terms of value? However, for this, we're also going to group by customer state and sum the revenue, and also sort the revenue to get the highest state revenue. So let's put down in a markdown note. So for this, we will also going to use group by customer state and sum the revenue. This is our code here. So state revenue equals to df dot group by customer state by revenue bracket close revenue dot sum bracket close. Then we sort the revenue. We sort the revenue to get the highest state revenue. Get the highest state revenue with this code. set state underscore revenue sorted equals to state revenue dot sort values bracket close ascending equals to false based on our machine default. It's true, but we have to convert it to false here. So then let's copy our previous plotting code that we use here and change some of the parameters so that I think it will be faster. I don't want this thing to take too long. So let's go. So we change our fixed size to 10 and 6. Let's change this one to 10 and 6. Then we change our company profit margin to state revenue. Let's change this to state revenue. Since it's state revenue I'm looking for, state underscore revenue dot sorted underscore sorted dot plot dot kind equals to bar, and change the color to purple. Let's change the color to purple this time around. More purple this time around. Purple. Then we also have to change the title. Our title for the graph from profit margin by company percent to total revenue by customer state. Total revenue by customer state. Total revenue by customer state. So we also have to change the x label, our x, that is our independent variables, to state from company. Let's change it to state. Then our dependent variable, which is y label, we change it from profit margin percentage to what? To total revenue. Total revenue. Total revenue. And our PLT sticks to 90 this time around. Let's change this to 90. So let's check again before we run our code for this question number 4, which says that which state has the highest sales in terms of revenue. Let's look. State revenue is equal to the F. The F is twice here. You have to edit this. The F does group by customer state and revenue dot sum bracket close. Then we saw the revenue to get the highest state revenue with this code. So state revenue underscore sorted equals to state underscore revenue dot sort underscore values and ascending order equals to false. So our plotting also we change from fixed size to 10 to 6. Let's run it first and see what will happen. Good. As you can see, this our total revenue by customers by state. You can see Minnesota, who has the highest, and Alaska was the lowest in this total revenue by customer in the state. So let's go to question number 5. What is question number 5 says? Question 5. Let's go and check question 5. Question 5 says what is the state relationship? What is the relationship between units sold and profit? Let's copy this from our business objective. Let's copy this and go to the next line. Put it here. That's question 5. Let's turn it to markdown. Let's run it. That's question 5. Let's give a cell below it. 5. Because of time, we are going to use scatter plot on this question 5 to answer the relationship between units sold and profit by copying our graph code from the above and change the parameter. So let's copy our graph code from above that we just used recently. Let's copy this and paste it here. And before that, let's just write our notes. Let's run this back. Using scatter plot. Using scatter plot. We are using scatter plot here. So let's change the parameter. On this state revenue, we have to change it completely. Change this to completely. Then we now change it to plt scatter, plt dot scatter bracket close square bracket. Now say the air dot unit sold the air square bracket profit comma as a color equals to blue. Then we change our title to unit sold versus profit. Unit sold versus profit. Then we change our hex label to unit sold. Then we also change our Y label to profit. Then this PLT estate, we remove it completely. We change it to remove this one completely. We change it to PLT.grade true is equal to true. PLT.grade bracket close true. So let's run our code here for the scatter plot to answer this question 5, that is, what is the relationship between units sold and profit? Let's run it and see what we have. As you can see, this is our unit code against our profit. The profit is on the y-axis, while the unit sold was on the x-axis, as you can see. So let's go to the next question, which is the last question, I think so. What is the last question? Which product category generate the most revenue? Let's copy this. Before we now go to our recommendation, so let's go down and copy this here. Then we said this one is question 6. Question 6. Let's change it to markdown and run it. So let's give our cell below. By answering this last question on this project of our business objective, of which product that generates most revenue, we will use group by category and sum the revenue similar with what we have done above by grouping the category and sum revenue. So let's answer these questions by grouping by category. Grouping by category. And sum the revenue. Similar to what we've done earlier on the previous question that I've done earlier. So let's use our code. We said category revenue equals to the f dot group by the f dot group by bracket close category square bracket revenue dot sum bracket close. And we have to copy the previous graph that we used. By copying the graph above, I will also change the parameters variables on this particular code that we are going to use here. So let's copy this our graph formula here that we are using earlier and change the parameter that I need to change. Let's copy it and paste it here. So we change this one to 8 to 6. Then we change the scatter plot. We change the scatter plot completely to category. Let's change the scatter completely. So PLT to category just revenue. Category underscore revenue underscore revenue and change let's copy the above method that we used before to make it very fast. Let's copy here. Let's copy this one to make it very fast instead of typing it a lot of time. I don't want this particular project to be too long, so that's why we are using this. We change this to category revenue category revenue. Then we change the color to light sea brown. Let's see it is light brown. Let's change light sea brown. And what is change title to total revenue by product category. Change it total revenue by product category, category, category by product category. So we change our S label to product category. Category. Then we change the URI label to total revenue. Then we change this one, complete it, and replace it with rotational 45. Let's see rotational 45. I stick, BLT, S stick. Let's Command C. So let's copy it. Let's put this one here. So let's put this 45. So I think we are set to go. So let's run it. Let's run it and see what we have on this last question to know which product category generates the most revenue. Let's run it. Oops, they type in error somewhere. Let's find out what's the cost of it. There's something going on here. I think there's something going on here. Let's run our code here. I think let's copy it and put this here and run it again. Oops, what happened? There's something going on. The color, I think the color is invalid color light zebra. I think that color, let's change the color to, the color is not, let's change it to yellow, or let's change it to category, product category. Let's change it to something. I will change it to, let's what's picky. I really like this C color. I wonder why it doesn't come up, but let's check for another color. Let's say like light. Let's say light blue, because light blue. Let's run it and see. As you can see, here it comes. This, let's do this one. You can see that alcoholic and the soft drink, tea was the highest. Alcoholic was the highest. As you can see, total revenue by product category. You can see the alcoholic is the highest, followed by tea, which carries something like 1.6, and alcoholic was about 1.6, followed by soft drink, and coffee is the last revenue by product category. So this leads us to the last content of our exploratory data analysis on soft drink total sales. Use number 2, insight and recommendation. Based on this exploratory data analysis is conducted, here are some of the business insight and recommendation could be drawn below. 1 is maximize revenue from top companies. Let's run it the markdown. Insight, as you can see that company like Coca-Cola has the highest or generate significant revenue compared to Pepsi and Dr. Pepper. Recommendation, if both firms come in partnership or co-branding, they will maintain top high revenue by increasing their market share in the market. Is target sales with high revenue. Let's run it down and let's run in the markdown. And our insight goes, if we study the graph above, we can see some certain states like Minnesota, Hawaii, New York, and have the highest revenue compared to Alaska and Arizona. And unrecommended goods does. An increase in marketing and distribution effort in high revenue states with loyalty or promotion program with local retailer will further increase higher performing market more in those states. Let's see the graph for that, which is this revenue by state by customer state. You can see the customer state, you can see the revenue, you can see the state. Minnesota is the highest and Hawaii, then followed by the last two states, which is Arizona and Alaska, and that's number two for the target sales for the revenue. On our last insight and recommendation, which is balance between units sold and profit, let's run it on Markdown. Insight: there are some products that sell in high volume, but they don't necessarily generate high profit, vice versa. And our recommendation goes thus: to strike a balance between volume driving and profit driving products. We ensure that products with higher sales volumes but low profit margins have an optimized supply chain or adjust pricing strategy for high profit but low volume products. Explore ways to increase awareness and visibility. That goes back to our diagrams above. As you can see here that Coca-Cola was very high here in total revenue by company. But look at the profit margin what they have here. They are very smaller than Dr. Pepper and Pepsi, as you can see. And by this, make us end the today's exploratory data analysis on soft drinks to that drink. Thank you and God bless.